Did you start? Hi, all. We'll start in 2 minutes. Just waiting for everyone to come in. Good evening and warm welcome to everyone. It is my great pleasure to moderate our very first faculty talk to be conducted online at Avani. And for our induction, we have none other than architect Vineeth TK. Architect Vineeth joined Avani about a year ago as an assistant professor of architecture, where he began as a member of the first year integrated studio team and is currently serving as a member of semester 7 studio teaching team. In addition to that, he also leads a series of open workshops on digital tools in architectural representation. Vineeth is an architect by training, working at the intersections of architecture and technology, with over 8 years of experience in professional design practice both in India and the UAE. He graduated from the AA School of Architecture in London in 2014 and received his B. Arch from MS Ramaiah School of Architecture in Bangalore in the year 2009. Vineeth brings with him a range of design and representation skills in 2D and 3D, but also prototyping skills such as carpentry, robotics, and Arduino. With his father, Vineeth recently established a design practice in Kannur called Vivid, becoming a part of a small but growing number of emerging architectural practices in the region that remain invested in architectural technology thinking. His talk tonight is titled Generative and Algorithmic Design in Housing. The talk will be around 25 to 30 minutes long, followed by 30 minutes of question answer session. For our audience on YouTube, please leave your questions on the comment section. My colleague Afifa will be redirecting them. Please welcome Architect Vineeth.
Thank you, Jill. Thanks. Good evening, all. Before we begin the presentation, I would like to thank all my colleagues and Avani graphics team who work in the backstage. Yeah. So, thank you all. So, I'll share my screen now to begin with the presentation. So, my interest in architecture and technology has been rapidly evolving, and I'm always in an exploration stage where in 20th century through an organized science and how technology has been rapidly evolving. So I try to be part of it, and its role has much larger influence in interaction or relationship with human, and it also has a capacity to rethink about our conversation to the world. So I think everyone now would have experienced during this pandemic, like you have experienced the power of communication technology. So my interest in the field of architecture is enveloped by technology and understanding the way it formulates our lifestyle. Since the contemporary architecture practice can't afford for my experiments with trial and error, and academic environment like Avani should be a platform with much larger contribution to the discipline. So I was fortunate to study at Architecture Association School of Architecture. The AA was established as a student-centered collective in 1847. So AADRL is a design research program which was founded by Patrick Schumacher and Brett Steele. Patrick Schumacher is director of Zahavi Architects. So it's a 16-month post-professional design program, so leading to a mark in architecture and urbanism. So DRL has been organized as an open source design studio dedicated to systematic exploration of new design tools. So DRL is led by architect Patrick Schumacher, then Shajay Bhushan, who leads research group at Zahavi Architects, and Theo was my director, AADRL director, and Rob Smith was my course tutor. So I was very lucky to have all of them and contribute their contribution towards the project, which I'm going to present. So the project rethinks high-density urban housing typology through the removal of lift course and corridor circulation by employment of an exterior decentralized lift system. So we look at the future requirement of housing for rapid population growth, and is expected by the year of 2050, the population will proceed to 10 billion. So this large population adds another layer of urban sprawl in existing metropolis. As a result, the home-to-work relationship widened due to long commuting time. In design research, we had case study approach. So we looked into Robin Gardens, which respond in bringing more communal and social interaction in housing, with the concept of pedestrian street above the ground in the building. As a housing project, it respond to bring in more communal and social interaction, but this has failed due to the accessibility issues. So we look at existing building typology, where units are distributed, apartment units are distributed along the corridor or along the circulation system. This is a vertical typology. So we have a core at the center and apartment is distributed along that. So we look at opportunities of after we remove the vertical and horizontal circulation cores and corridors. There's a possibility that circulation system operates on outside of the building or on the surface of the building, which will enter the building surface used as a circulation infrastructure. So what you get to see here are the geometries, possibilities if we rethink on the circulation system, the conventional circulation system. Next, we looked at possibilities in network building, zooming out to an urban scale. City could be just a building where architecture acts as a medium of urban mobility and allow a decentralized and network organization of space. So stigmergy is a method of indirect coordination of agents of action, like you see in ants. The principle is that the trace left in environment by an action stimulates the performance of next action by the same or different agents. The stigmergic behavior by ants, which could be embed more circulatory logic and algorithm-based design. We try to imitate in a on a digital platform. In global scale, we use stigmergy as a computational technique in deriving network optimized path for circulation in the site. So here, what you get to see here is few catalogs. The first row show main network organization by agents of similar behavior with multiple starting positions. In second row, you get second hierarchy created by another set of agents, which was deployed simultaneously with various input of velocity, force, density, and population of these agents. These are few catalogs of outputs and varied density. Since the building topology is driven by external circulatory system, we looked at how to even control the height by density of the stigmergy train. The higher dense train becomes the larger surface area where we need, that becomes a main circulation system. So these are catalogs with various we explored with various inputs and we kind of shortlisted few of them. So we use procedural modeling technique in Maya to convert 2.5D stigmergic trail into a building mass, which followed few sets of rules: junction studies, clustering, density studies, and site control. So the main network path is translated into a three-dimensional geometry by analyzing the efficiency of lift movement and deploy a different set of rules in converting to stigmergy tree. So to achieve an optimized path to reach two endpoints, the void is created at the junction. The void was created based on a continuation of the surface, translating from one main network to a secondary network path. This catalog shows how the junction of the geometry, where there is increase in number of diversions from the main network. So the exploration become more complex as we further develop on, on this three-dimensional geometry. These are few outputs which we got. So this was another junction studies by clustering geometries. So, so we gradually increase the number of clusters as well, which again becomes more complex in terms of circulation movement and the provision of void. So after the research on different methodology on translating the stigmergy, we decided to translate based on linear junction method. The catalog showed different hierarchy in plans of translating the tree. So these are experiments, modeling exercise which we took in mind. So next stage for the project, or which something which ran parallelly, was building a net prototype which actually can move on a three-dimensional surface. So either it should climb a vertical wall or it climbs down. It moves also on the lead. Basically, it should move in a three-dimensional format. Thinking about the new lift system moving on the exterior surface of the building, the design criteria were a three-dimensional movement, uh, balance the flow horizontally, so during its motion, attaching to the surface, accessing in and out of the building, and avoiding congestion and heavy traffic zone. So these are the initial studies. We were trying to build few prototypes based on electromagnets. There were so many failures while doing this, and it took almost 6 months to develop a working prototype. So these are essential part for the lift. So this is a final working prototype. Some photographs. Then we changed the size of it. We made it as smallest as possible, and we tested it on top of our studio ceiling. So basically, it works with two magnets. We have moved away from electromagnets because that that was a bit heavy, and so we used heavy magnet, high power magnets. So with three-dimensional universal movement, one of the challenge for us is the flow balance. We still keep the sphere geometry that has this ability of sliding the flow while mobile unit is moving. Instead of using the sphere, we developed a new geometry which slides out from sphere. This geometry creates maximum connection with other lifts for temporary use, which I'll be showing in coming slides. So Intelligence of the mobile unit become an essential factor to be considered when we have a large population. We need to look at avoiding pollution, avoiding traffic congestion, following efficient path. We wanted these units to collect solar energy when it's in an ideal state, addressing a sustainability factor. So these were some of the parts which of the prototype where we essentially use servo motors, Arduino, and few light sensors and photoresistors and IR distance sensor. Then the initially I had showed you a digital version of a stigmergy. Then we try to experiment uh, in a physical space. So we had this setup where we have projector on top, which tracks the movement of these small robots, which sends information to the coding computer. Then it sends back information and puts a trail on the floor, something. So then it based because it had light sensor, it keeps following these light trails which it created by itself. So we gradually added the number of units, and it also we have to ensure that it doesn't collide each other, and we put few obstacles in between. We had difficulties in for the robots in sensing lights even in the dark, like so that's why some of the objects get hit. So this is the final lift design, where we kept the internal geometry in a sphere format by providing axes on all four sides. So some of the vendors, so it can stack one above the other. So it's designed in such a way that it respects the floor heights. A 3D printed model. So then we have to look in the high-speed elevators in existing buildings, which help us to set the speed values for the computation purpose. So the system allows for efficient mobility between public programs that are mixed with housing through this new lift system. In this scenario, the node will keep updated the traffic amount information, and when too much of traffic happens in one specific routine, this area node will shut down and prevent other lifts from make, coming into the particular traffic condition. What you see in red color is the public program, uh, with more lifts traveling towards it during the peak hours of the day. So you can check the time on top and the average traveling time. And it also says how many lifts is required. So we have kept lift population of 102 and apartment population of 1,600, 1,559. So these two sets of geometry aim to find out the proportion of lift compared with apartment numbers. And so basically what we are looking into is what's the proportion required for these many apartments. Through the first simulation with set of 10% of whole apartment numbers is good enough to meet the entire uh, apartment requirements. So after testing the second typology, so these were, we tested few typologies which was previously developed in Maya. So the formal Q testing illustrates the rough percentage of lift population in relation with apartment numbers. After decreasing the lift population, the result shows the traveling time is even higher than the condition with more lift population. So we have choose location site in China, located in between the city center and airport, in order to address working and living relationships that have emerged between dense metropolis and the transportation hub, emphasizing on the mobility speed. Maybe I'll skip through these slides as we're running out of time. So the site was around 1 kilometer long, the, where we restarted applying whatever codes we had developed into a particular scenario. So we had few layers where express maglev was there, parking space, then public landscape, then the building was. So wherever the narrow space is there, that becomes apartment, and wherever the junction is there, that becomes a public space. So section of a 3D printed model of the final design. And we have also tested the facade system prototype. The challenge for us was to create a facade opening and closing system, which is the access between the lift and the apartment. So the lift also allows to create an additional space for the apartment based on the user demand, addressing the building life cycle through the urban lifestyle. So here we tested when lift moves, even the facade, facade got very dynamic in nature. So based on user's demand, the facade can open or close. If it's closed, lift can move on the surface of that, otherwise it has to take different route. So some of the simulations. So few renders. So this is so we imagine the lift, we can call lift based on our demand, and when a lift is approaching, the facade gets closed. It also connects the maglev train station. Thank you. I don't know.
Thank you, Vineeth. Thank you so much for the wonderful talk and illuminating
Thank you.
presentation
Thanks for the
on
opportunity.
popular demand. We now open the floor for the question answer session. And so, people who are watching us on YouTube, please leave your questions on the comment section. We can take it in between. And students here, we can have a interactive section with Vineeth. Anybody would like to go first? Afifa, you can parallelly look at the comment section.
Hello.
Hi, Hari.
Yeah. So I wanted to ask you, actually, how many softwares were involved in the whole process, and
Uh,
which?
so we used processing for coding and processing and Eclipse. That was mainly for the coding. Then for prototyping, we used Rhino. Then for model making, we used Maya and 3D Max. Then for rendering, we used Wheeling. Um, and for presentation in design. So we have to be equipped with all those. Yeah.
Did you study the processing from A or before going to A?
So we had a very intense workshop first first month, second month. Uh, that was quite intense workshop. That's when we learned all these programs. So first 2 months has been quite dedicated in developing this physical analog modeling skills and digital skills. So there were two workshops. One mainly focused on physical experiments, and the second one focused on digital simulations and modeling techniques. And the since we were 4 member team, we divided work among ourselves because the coding requires more labor, and if some person in the group is doing the coding, they did it for the entire year. I mean, they won't get in along with. Uh, they don't get into other parts of the world because it's quite intense and it requires so much of time. And did I clarify your question?
Yeah. Yeah.
Thank you, Hari. Any more questions? You can also ask your questions in the chat box if you don't want to speak up. Ashish, you are going?
Yeah, so I wanted to know uh, how things actually work in VR, like what's the actual process and all. Like how's it?
And
How is it like a group work or?
so it's been a group work. Always it's a group work, and we learn. It's an open studio. So like in Avani, we we prefer group work, and we learn from our peer groups. So there's always an influence of our peer groups in the project, and it's quite intense for a 16 months program. So, I remember there wasn't any Sundays where I could break. Only break was Easter and Christmas holidays. anything else, Ash?
Yeah, that's it.
Okay. Thank you.
Thank you, Ashish. Afif, are you able to see the comments now?
Yeah, I think there was some technical problem, but now the comment
Yeah,
sections are live.
yeah, people on YouTube, you need to refresh the link to get the comment box there. Sorry for that inconvenience. Any more questions from other batches? Please feel free to use the chat box.
Hello, sir.
I know.
സർ സാർ അപ്പോൾ ഒരു ഡൗട്ടുള്ളതെന്ന് വെച്ചാൽ ഇപ്പൊ നമ്മൾ പ്രോഗ്രാം ചെയ്യുമ്പോൾ അതിന്റെ സ്ട്രക്ചറൽ അനാലിസിസ് അതെങ്ങനെയാണ് അപ്ലൈ ചെയ്യുക? മീൻസ് അതും പ്രോഗ്രാമിൽ നമ്മൾ ഇൻപുട്ട് കൊടുക്കാൻ കഴിയുക?
So, I mean, it's quite hard to address all the issues. I think that's a slide which I didn't show due to the limited time, but we also did the structure analysis portion where we use Kango and Grasshopper. Yeah, but that wasn't very intensive study. It was quite basic. We were mainly focusing on the core concept of the project and developing them. So that, we know that okay, there are so many issues which need to be addressed, but yeah, it's mainly the proof of concept and what we are trying to address. I just so there wasn't any particular inspiration.
Sorry to interrupt. Let's just repeat the question so that everybody sees. So there was a question by Jose. What was the inspiration behind such a project? Vineeth, please go ahead.
Just there wasn't any particular inspiration and the big meaning. It's all become part of the process. We didn't start by thinking, okay, we remove the left, and that wasn't our primary goal. We were studying the issues which can be addressed through architecture. That was our primary intention. So initially, we even did a research on wireless energy and how that gets transferred, how that changes the lifestyle, which I think right now it's commercially available. When we were doing the masters, we kind of did the coiling and made small wireless transfer. Yeah, but all those were part of the. It basically evolved, and I don't say there was any particular. It wasn't a top-down approach.
Hi, Vineeth. This is the second time I'm actually attending this project because it's then and now there's still like so many questions that come to my head whenever I see your project. I think today while you were going through this, one thing that cropped into my mind was this whole the one of the fundamental aspects of this project that what I perceived or I interpreted was the fact that you take something like circulation, which is conventionally something that happens within inside the buildings, and that becomes a very dynamic structure outside of it. So I'm sure your research would have involved a lot of movement study, and that kind of would have factored into the project. But also, you talked about the facade and how this kind of, it's a very different kind of interface you're creating, where the movement is outside of the building. How do you think that, was there any very interesting observation you made, or inference that you made in this project, where this idea of this interface came into play? What happens outside, that in that public space, and the private spaces within. So it's kind of like this veil between these two realms. How did you sort of imagine it, and how does that play into the project?
I think one of the key challenges or questions which was raised during our juries, like we have jury every 2 weeks, so it was mainly the privacy issues. Like just imagine someone going through in front of your apartment, and so that's when we started thinking of the facade system, and it should be a method. And there was a question famous, how much does your building weigh? So that question was asked. Then we, uh, I think something which I didn't show in the presentation was how the facade system works, because it requires more engineering and technical details. We had structure consultant called AKT who worked with us. Uh, and regarding the accessibility, we were thinking on connecting social and private spaces much faster. But there was another question which was raised, is like this doesn't seems to be encouraging the social life, but actually by accessing these public space much faster and easier based on your call, I think that's where it changes the way we live. Did I answer your question, Vishnu?
Yeah, I mean, that's actually, that aspect of the project is what interested me the most. This idea of, um, you're kind of redrawing these boundaries of public space, social space, and private space, in a very dynamic way. So
So
that's
it's always a enclosed space. When we say public, we don't. In this particular project, it's not an open air because building surface need to be curved, where it allows for lift movement. So we can imagine a rooftop garden or something. So yeah, I mean, in terms when you think from conventional side, there are lots of issues to be which still need to be addressed.
yeah, very interesting concept. Thank you, Vineeth.
Thank you.
Hi, sir.
Hi, Shivana.
Yeah, the presentation was wonderful, and I was just wondering about, so this cabins are moving outside the building, right, on the facade.
Yeah.
So how are the other external factors like the wind and all the other outside factors affecting the whole movement of this whole system? And yeah, mainly wind and other outside factors.
So this is something we had thought before we think on external factors. We the initial challenge was how does this lift actually move when there is, I mean, the self weight of it, that need to be reduced. So even while making prototype, we realized that okay, this much larger volume, we need to somehow manage the weight of the lift. So that's when we reduce the change from electromagnet to magnets, and we provided only two magnets. So these questions, we were trying to address this from lift point of view of self-weight of the unit. And regarding the external factors, that's something which we haven't done in simulations or studied that. We basically done structure analysis of it. So that I think there's more to explore within this project, more on technical side, and there's a lot more to explore.
Thank you, sir.
Vineeth, there was a question which might be there on everyone's mind. Could you give us more details about doing masters from a foreign university and something more about a masters in A?
Okay. So I think I came to know A when there was a building in Bangalore, St. Mark's Road, which is placed in St. Mark's Road. It was done by architect Vivek Shankar. So after completing the thesis, I was like, okay, I need to work with them. So I kept on applying. There wasn't any response. So I waited for 3-4 months. I got response after 4 months. Until then, I was a bit jobless. Yeah. But I was a bit aspirant on going there itself. So that's where I worked for almost 3 years in Bangalore. So I think that would be the first stepping stone in getting to know A, because he is DRL alumni. He did his master's back in 2000. That's when the program was actually formed in 1998. So, and the work over there, the way he approached any particular project, that that was that also gave a base for what I want to pursue. I think that is a key point. I think a turning point in my life where I think choosing to work with someone like that, and it wasn't planned. Like I just want to know more about AA. I'm not sure whether I'll do masters or not. But after working there for almost 2.5-3 years, then I realized, okay, why don't I give it a try? Yeah, and that's when I moved there. But being at AA, and that's a special case actually. Being in that particular environment where people like Saadi or Kengakuma, they just walk in. I mean, it's their own institute. So we get a chance to meet all these great architects, and they are always part of our jury. Uh, so their feedback also gets involved within our project. So that I think all those contributed in developing such a project. Yeah. And the life at A is, I think that's something which need to be experienced. I'm not sure I will be able to explain that.
Thanks, Vineeth. That was a great journey. Kush, do you want to go?
Hi, Vineeth. Sorry, there's a bit of a lag.
Hi, Kush.
Glad to be here, and I was watching you on YouTube as well, so I was switching between two different modes. Vineeth, we've talked about your presentation, your work, your background, and I'm just sort of thinking about architecture students who are fairly advanced in our BArch curriculum. And there are students who are sort of beginning to feel interested in the connections between architecture and computation, architecture and artificial intelligence, architecture and parametricism. And I'm wondering if there's a way in which you might sort of locate your project, but as a starting point for undergraduate students who want to begin to sort of explore some of these themes, potentially in their thesis projects. So how would you advise, how would you guide such queries coming from students at the BArch level?
I think Avani give us a platform to explore that. So that's why we have a new design and being part of the S7 studio. And I think we are trying to explore something new there out there. So I see that would be a turning point because it's quite open. Like when we frame our design studio and all of you accept that, I think I see that we should start from a small step first. So it was quite glad to be a part of that S7 studio and frame that project. I'm quite waiting for the to complete that and see where it leads to. And from there on, I think that's where I see okay where to lead it, and this is the first experiment what I want to what we as a team are trying to explore in the undergrad design studio. So I think this can be implemented throughout design studios.
Yeah. Thank you, Vineeth. Yeah, I was just sort of just being mindful of a diversity of sort of student who are attending this talk currently, and just thinking about that kernel, that seed of a project, and so starting point not just limited to a particular studio and its formation, but starting point as sort of thinking through this area of inquiry that may interest students either now or in the future. And so if you were to, let's say, recommend either a set of projects or texts or even observations in the world that could begin to anchor some of their queries, how would you begin to advise students who might be interested in that realm?
I think based on that's something that where and I have initiated this software classes and Avani. So I see a great interest from there. That becomes a platform to discuss all of computational aspects, and I think from there we take it forward. And there are other faculties who is also in this computation field. I think they are also part of this program.
Thank you, Vineeth. Yeah, thanks.
We have 5 more minutes for the Q&A. Yeah, that's Pawnami asking a question.
Hi, sir. Like I really like the project, and I was curious to know that how are you like from all these projects you have done, like how are you taking such ideas or the design to your current project that you are doing? So is there any element that you are following, or is there anything like that?
So this always a challenging question when it comes to a commercial project, there is always a time frame which we need to deliver the project, and there is no uh, platform to do trial and error, which happens in a research research platform. But I think whenever we get time for a particular project, which is quite rare, but that's when we try to implement uh, the computation aspect. And this can happen only through competition, not through a commercial project. I mean, it's quite hard, and especially being a small firm, and so it's quite challenging unless until we have a separate research group like some bigger firms like Zadi, and like they have separate research wing and some people who looks after the commercial. So it's not quite viable in commercial aspect to explore or implement all these.
Were you able to read Purnami's question in the chat box?
Could you please ask? I mean,
Hi,
I
hi.
didn't understand.
Yeah, I was asking whether you're looking into the future and uh, you're imagining that this kind of movement systems will be needed in a time, or how do you see existence of such systems in the future?
So this kind of project requires advancement in all the fields in terms of communication, engineering, and to be frank, I don't see it in near future. But the primary goal of the project was to address much larger housing issues, which is going to come in the near future. So, with our aim was to, with available technology and resources, we should be able to have proof of concept on what we are proposing, and we have to use the existing technology and not to limit ourselves. Uh, how do I put it? Not to limit ourselves in thinking much, not thinking beyond what's in the conventional system, but what we have, and with that, what we do. That's something which we need to look at, rather than looking at the final output of the project. That's something which I had learned as well. We didn't think like, okay, in 2050 artificial intelligence will rule, because we don't have proof for it. Only proof was what we could do. Even when I show some of the simulations, physical simulations, it was we used all those light sensors, which was readily available in the market, and it's mainly a proof of concept.
Okay, so thank you.
With that, I think we'll wrap up. Any more last question?
Hi, ma'am. It's not actually a question, but I just wanted to say that with the level of knowledge that I have now as a fifth year architecture student, some part of what you presented was a bit difficult for me to understand, but still, it was really an eye opener to understand that there are such possibilities and opportunities in architecture when it comes to software and everything. So, thank you so much.
Thank you, Aishwarya.
Vineeth, we have two questions in the comment box.
Yeah. So, Akifa had asked any suggestions for undergraduate students who are planning to get.
That's actually a question from the YouTube. One of our viewers has asked.
So I think that requires a change in our approach and what we are trying to learn, at least in undergrad level. And I think it comes at the university level of what we need to learn, or it could be a special program. That's when it's Rat Lab Studio or based in Delhi, where they conduct special workshops, or they are developing a course by itself. So I think for now that would be the way to explore this at undergraduate level. Then next question is asked by Andrea. How do you weigh algorithmic design thinking with conventional one? I think when we talk about generative design as an architect, it's our role and where we position ourselves, like there, and based on the project. Uh, Sometimes in demand, I think we have to choose whether it should be a generative or whether we should implement algorithmic design thinking for, for that particular project. But not sure whether we can really weigh each other. We should find equal balance sometimes. But in a research platform, I would go for algorithmic design because that helps in developing and contributing more to the field, especially when artificial intelligence is gaining on the other side. And we have to start thinking how that can influence architecture. So, from one side, technology is improving at a higher speed, but when it comes to art, it's still limited with many challenges.
I think we are exceeding the time. Let's wrap up. Oh, you have a question, Afifa?
There's actually one more question, one last question, if you can take if you have time from the YouTube. So Nimisha has asked, how is generative design helping in your practicing career?
To be frank on that, I think it's not really helping because most of the projects they ask for submission in 2 weeks. Yeah, and coding is something which I don't think I'll be able to do in 2 weeks' time. And, so it's all about resources, time, and the commercial viability. So, but as my office grow, I intend to participate with the team because they contribute a lot to the projects. So that need to be treated separate, but there could be small interventions based on the project requirement. not everything can be adopted for a commercial.
Okay, good to go, Afifa. Okay, with that, let's wrap up. Once again, thank you so much, Vineeth, for your time and presentation. And I would also like to thank Mithun for the IT support, Afifa and Dr. Kush for being wonderful partners in organizing this, graphics team for the brilliant poster, and Reshma for the social media support. Last but not the least, thank you all for joining in and making it an eventful evening. Thank you.
Thank you. Thank you, Vineeth.
Thank you, Julna. Thank you, Vineeth.